A cold dawn on the Mussolini Canal near Anzio. By noon, trench steel felt thin. The Reason rode on a box the size of a suitcase with tracks and a cord that never left its belly. Operators hid behind a berm, hands on a control box, while a wire-guided crawler slid under concrete and hulls. The old rule that cover meant safety broke in minutes. Subscribe. New Evidence First World War II videos every day. The hour was just after first light on the 24th of January, 1944. The map pin sits on the east bank of the Mussolini Canal, 3 kilometers south of Padiglione, under low winter cloud and wet reed beds. The Anzio Nettuno beachhead had been opened 2 days earlier by Allied landings, and both sides were still feeling for the edges. German engineers had set a thin crust of mines and tripwires, then pulled back to culverts and drainage ditches overlooking the canal. The old rule said bunkers and tanks were safe if their bellies never left cover. Armor parked behind a rise could not be reached by ordinary satchel charges. Infantry inside a concrete cell behind a wire obstacle could wait out a barrage. The rule relied on standoff, the distance between the threat and the protected volume. The surprise mechanic was small and low. A tracked box, knee-high and barely longer than a man's arm span, carried a charge of roughly 60 to 100 kilograms. It moved at a walking pace and paid out its own control wire as it went. At the end of the wire, an operator lay prone with a wooden controller and a battery-fed panel. On that morning, one crawler nosed down a drainage cut, then under the apron of an Italian farm culvert. The charge detonated under the slab, not in front of it. Blast did not have to punch through a face, it lifted the whole cover from below. A shock report from an American engineer platoon log lists one culvert rendered air-spaced within 2 minutes, the ceiling fractured along the rebar grid. One hard metric shows why it mattered. A belly contact detonation from a 90-kilogram Amitol block, with zero standoff and confined by earth, can exceed the sheer strength of thin armor and set any track pins within a meter radius to failure. A range table in a captured German Pioneer leaflet notes an effective killing distance under hull of less than 1 meter for light armor. The geometry is simple. The crawler eats distance, and the wire returns the operator's hand to the blast site. Across the Anzio rim, American and British units found that the new device did not respect visibility. A dawn mist over the Pontine marshes gave the crawler a curtain, but the wire told the truth about control. If small arms fire did not cut that cord, the vehicle reached the lip. Aerial reconnaissance photographs from later that week show crater mouths tucked under revetments, not in front of them, a telltale of substructure failure. The old rule also governed mines. Minefields force approach along lanes. Satchel charges ask men to cross those lanes. The crawler reversed that math. A pioneer team could send the explosive forward while staying behind their own wire by 300 to 500 meters, depending on the model and spool condition. The shock at Anzio did not come from rate of fire or altitude. It came from proximity achieved without a body. American reports from the 5th Army Engineer Section, dated the 26th of January 1944, count 4 incidents in which a previously secure culvert, gun pit, or parked half-track was breached from below or from the rear apron. In 3 of 4, the wire was intact at recovery, and fragments of the crawler's steel frame were collected and sketched. The device appeared again on the 6th of June, 1944, along Norman lanes behind the beaches named Omaha and Juneau. Here, the map pin shifts to the roadnet west of Bayeux, where hedgerows, sunken lanes, and farm walls create pockets of hull-down steel. The old rule said a wall and a hedge could hold back an assault even after naval gunfire. The crawler reduced that certainty by removing the wall's footing from the inside face. One logistics vignette explains the scale. A rail manifest captured near Rome lists 36 crates marked for Pioneer units, each crate holding one crawler and spares for control wire in 500-meter coils. A maintenance card from Borgward's Bremen Works shows unit serials checked in the 3rd week of January, 1944, typical of a last-minute push. The flow from factory to field ran through Army engineer parks, then by truck to divisional pioneer companies. Terrain set limits, and that morning at Anzio shows them. Soft reed beds slowed the small tracks and made the chassis squat. If the wire snagged on brambles or scrap pickets, the vehicle stopped. A decoded signal summary within 14th Army on the 25th of January noted that crews learned to lay a guide plank across mudlips to keep the nose from biting into a sump. A myth grew quickly that these crawlers hunted tanks across open ground like dogs. Evidence on the ground says otherwise. Unit after action pages from the 1st Armored Division list no chase scenes, only short prepared runs along ditches or walls, always toward a fixed cover edge. When gunners saw the wire and raked it, the device died where it stood, a burned box on its belly. By noon that day on the canal, the old rule lay in pieces along with a culvert slab. The breach did not look dramatic in the photographs. There was just a lifted rectangle and a sag in the road. Yet the effect stretched down the line because every culvert on every lateral became suspect. The contradiction is quiet. The new breach felt like chance, but the crates and cost sheets in rear echelons say it was policy. Numbers made it feel planned. One battery of crawlers could attack 2 or 3 points in a morning, each run under 10 minutes. Effective range for early electric models sat around 600 meters of wire, while petrol variants stretched to 700 or a little more. The charge mass stayed near the 90-kilogram mark, enough to break a girder in a light bridge span if placed well. The rule that cover kept men safe had held since the first trenches. That morning on the Mussolini Canal, a tracked box and a wire broke it fast. The map pin sits in reed and mud, but the effect reached into staff tables across 2 theaters. It was not an accident. It was a program. The human lever sat in a design office in Bremen in 1942. The Waffenamt Engineer Inspectorate, the Army's test and procurement branch for engineer equipment, asked Carl F. W. Borgward's firm for a remotely controlled demolition carrier that could put a charge exactly where a man would die trying to set it. The order flowed from Army High Command through the Engineer Directorate, then into a contract file stamped in mid-year. Production drawings show a simple hull with twin track runs, a forward bay for the explosive, and a payout drum for a 3-core control cable. The authorizing signature at the Army end belonged to a general of engineers whose office oversaw bridging and demolitions. His staff linked the device to pioneer battalions at corps and division level. A training syllabus printed at the Army Engineer School at Dessau-Roßlau in late 1942 laid out crew drills, controller layout, and recovery procedures. The document specified 1 controller per crawler, 2 men per team, and a preference for culverts, embrasures, and stationary armor. The order path continued through Borgward's shop floors. Production tallies list electric motor variants first, with twin battery packs and a rated silent runtime of roughly 30 minutes at a crawl. A later petrol model appears in second half 1943 worksheets, with a small 2-stroke engine and longer endurance. A cost sheet in Reichsmarks shows early unit cost in the low thousands, rising when electric components ran short, then dropping again when the petrol line stabilized. Obstacles came early and looked mundane. Wire insulated for the field cracked in cold weather, especially when kinked. A maintenance card from a pioneer company in Sicily records 3 failed spools after a week of rain, with insulation flaking under finger pressure. The fix came as a supply directive to issue fresh reels in sealed drums and to teach crews to lay the first 50 meters by hand to avoid snags. Training time was expensive. Pioneer companies already had to carry mine plows, Bangalore torpedoes, satchel charges, and bridging kits. Adding a wire-guided vehicle meant new drills and new spares. A weekly schedule pulled from a brigade file in northern Italy shows 1 hour each morning devoted to controller practice on dummy chassis, then 1 live run slot every 3rd day, with 1 in 5 runs lost to minor faults. The decision point arrived with 2 theaters asking the same question. In Italy, the 14th Army watched Allied armor use culverts and stone barns as shields inside the Anzio Rim. In France, 7th Army expected to fight among hedgerows and masonry farmyards along the low river line south of Bayeux and Caen. In both places, the engineer staff wanted a way to put explosive under the belly of cover with minimal exposure. On the 14th of January 1944, a requisition moved from the Engineer General Staff to the 14th Army Depot near Rome for a first shipment. Rail manifests list 24 crates. A week later, A separate order booked petrol variants for the West, with delivery to depots near St. Lo by late May. The paper trail shows parallel lines heading for two different kinds of walls. The human lever at the tactical edge was a corporal with a control box. He learned to read ground like a sapper, not like a driver. A training vignette from the engineer school describes the sequence. Raise periscope or binoculars above a berm, pick a seam or culvert lip, send a runner to check wire lanes for snag points, then drive the crawler in short bursts while the second man feeds slack. The detonation switch stayed covered until the nose disappeared under the target face. Authorization tightened the device's roll. Orders from core engineer sections said no free hunting and no night games without pre-laid wire lanes. Ammunition was rationed by charge blocks, not by chassis, to encourage recovery of the vehicle when possible. The aim was not to create terror, but to open a breach where none would otherwise exist. One friction point lay in signals discipline. Wire guidance avoided radio interception, but line of sight still mattered. In hedgerow country, the controller had to crest a lane to see the nose of the machine, which exposed him to small arms fire. A training fix required the team to use a mirror board or a short periscope to stay behind the berm, trading visual clarity for safety. Costs shaped the rollout. A production tally from the Bremen Works lists several hundred units completed by the end of 1943, with a goal to double that by mid-year 1944. Each early electric chassis cost roughly the price of a light car, and spare wire reels were both heavy and fragile. The petrol model brought the price down and eased the strain on battery shipments at the expense of silence. A quiet decision ended the debate about whether to hold the machines for bridge sabotage alone. A directive in February sent a portion to assault pioneer companies attached to infantry divisions near both beachheads. The rest stayed earmarked for culvert denial during retreats. In effect, the Army chose to spend the devices forward, where the breach effect saved infantry minutes and sometimes lives. Final authorization reached units as a set of laminated drills. Each drill defined distances, times, and responsibilities. One standard run aimed for a 2-minute crawl over 100 meters of ditch line. Another practiced a 90-degree turn into a barn door and a halt under an inner wall. In both, the last motion before detonation was always a small reverse, to settle the nose against the target face. The decision point was not a single signature, but a convergence of need, cost, and time. Italy and France both offered targets that the device could reach and break. The human lever at the factory signed off on a simple hull and a reliable reel. The human lever in the field put a gloved hand on a wooden box and chose when to press the switch. By late May in Normandy and late January at Anzio, crates had been emptied and spares sorted into tins. Crews knew which wire reels kinked and which controllers had sticky toggles. The device was no longer a trial piece, it was part of the assault kit of Army engineers. With that, the rollout began. The system was a small tracked carrier with a shaped space for an explosive block and a spool that paid out control wire as it moved. Early versions drew power from electric motors and carried batteries sealed against splashes. Later versions used a small petrol engine that gave longer runtime, but a faint signature of sound and smell. Both shared the same method: stay low, go slow, and deliver a charge to the least visible face of a target. The control link ran through a 3-core cable. One core handled steering impulses, one drove the throttle or motor control, and one armed and fired the detonator. The operator lay behind cover with a wooden controller box about the size of a field radio. Toggle switches and a small joystick translated hand motions into current changes down the wire. Reliability and controlled tests sat near 2 and 3. A factory test sheet from Bremen shows acceptance trials, where 2 runs out of 3 completed a planned course of 100 meters with no stoppage. In field conditions, unit after action pages recorded about 1 in 2 runs reaching the aim point, with many failures due to wire damage rather than drive faults. The difference came from mud, small arms fire, and snag hazards in real terrain. Witness objects anchor these numbers. A maintenance card stamped in March 1944 lists common faults after 10 hours of use: track pin wear, wire insulation scuffing, and moisture ingress into the control box. Aerial reconnaissance photos from the Bayou area in June 1944 show fresh rectangular craters tucked under farm walls, a signature of underface detonation. A range table booklet printed for pioneer companies gives recommended standoffs, fuse settings, and approach angles for culverts, embrasures, and parked vehicles. The parts were simple, but had to be handled like ordnance. The explosive sat in a steel-lined tray at the front of the chassis, usually a block near 90 kilograms with a booster and an electrical detonator. The fuse was set safe until the last 50 meters, when the operator removed a guard and armed the circuit. Safety drills required a final check of wire continuity before arming with a simple lamp test on the controller face. Constraints shaped method on every run. Terrain mattered most. In hedgerow country, the crawler needed firm ditch bottoms or wooden planks laid by the team to keep from high centering on roots. In marsh, around Anzio, crews chose narrow drainage cuts with firmer clay underfoot and avoided reed beds where the wire could snag and drag the nose sideways. Fuel, in the broader sense, also constrained use. Electric models had a finite amp-hour budget, cold weather cut endurance by a third. Petrol models needed clean fuel and a choke drill that worked in damp. Supply notes from a Pioneer park near Caen specify small cans of fuel and a hand primer kept inside a waxed canvas pouch to stay dry before a sortie. The step-by-step method looked like a sapper drill written for a remote hand. First, pick a target face that is hard to reach by a man, the backside of a culvert wall, the inner side of a barn buttress, the belly pocket under a hull parked behind a wall. Second, plan a wire lane that avoids tangles, along a ditch bottom, under a fence, around pickets pinned by sandbags. Third, send the crawler in short bursts, stopping to re-angle the nose before each obstacle. The run ended with placement, not just proximity. A good placement for a culvert put the charge under the midspan, not at the lip, so the slab would lift evenly and settle crooked when it fell. A good placement for a wall sought the inner footing, blowing into the fill and creating a back lean that tools could widen. Against a hull, the aim was the underbelly or the track run just behind the first road wheel, where blast could shear pins and collapse the support. Two constraints always hovered over the run. The wire had to live to the end, and the operator had to see enough to steer. This led to periscope use or mirror boards to keep the head down, and it led to short runs with pauses where a second man cleared the wire's path with a hooked stick. In wet weather, both men wore insulated gloves because the control box could tingle when insulation was damaged. A myth said the crawler hunted like a free roving predator. Evidence from captured drill books and Allied reports overturns this. The device excelled in prepared runs, with a map sketch folded into the controller case and a wire lane scouted beforehand. It performed poorly as a surprise weapon launched blind across a field, where rifle fire could cut the cord in seconds and where soft soil stalled the small tracks. A logistics and training vignette shows the attention to detail. In a Pioneer company near St. Lo, instructors had crews practice rewinding wire onto spare drums to learn how to avoid kinks. They logged the number of turns and the direction of lay, and they kept a tally of how many times a reel had been used. A small notebook, now in an archive, lists a reel retired after 5 uses because the outer insulation showed cracks at 50-meter intervals. Witness objects also recorded command constraints. A decoded signal summary from 7th Army in early June limited use near friendly mines to avoid sympathetic detonations that could ripple across a belt. A ship's logline from a coastal barge moving crates along the Orne River shows detours taken to keep the supply line away from air attack. Production tallies shipped with the crates provided serial numbers so maintenance officers could track failure rates by batch. The system rewarded patience more than speed. Effective ranges sat between 500 and 700 meters of wire, depending on model and reel. Speeds were in the low single digits in kilometers per hour, with best control at a crawl. Time on task per run averaged 5 to 10 minutes, most of it spent lining up the nose for the final short push. The method promised something specific in the next act. To judge the device, numbers and parts are not enough. Field tests tell whether a rule truly broke. Anzio would show culverts lifted from below in winter mud. Normandy would show hedgerow walls opened from the inner face in summer sun. The cases are small on a map, but they turn on the same system in the same wire. Before crates went south to Italy or west to France, The device ran across a gravel lot at the Army's engineer strip near Kummersdorf on the 12th of September, 1943. Test officers marked lanes with pickets and tossed scrap wire into the path to simulate hedgerow debris. 2 out of 3 runs reached a painted culvert mock-up at 100 meters. A range table pamphlet issued that week recorded recommended approach angles and warned that tight turns on loose gravel ate track pins fast. A maintenance card filed the next day noted a frayed outer sheath on the control cable after only 3 rewinds. Logistics shaped the first trials as much as mechanics. Crates left the Bremen works by rail in lots of 12, each with 2 spare reels of 500 meters and 1 controller. A rail manifest dated the 3rd of October, 1943, shows a stop at Magdeburg for repacking after a drum shifted and cut its own insulation. Instructors at the engineer school added a drill to bind reel flanges with waxed cord before travel. A decoded signal summary to all depots repeated the instruction and added that controllers should ship in padded tins to avoid moisture ingress. Terrain framed expectations. Test lanes at Kummersdorf were flat and predictable. Italy and Normandy were not. In memoranda tied to the pamphlet, officers wrote that reed beds, ditch collapse, and hedgerow routes would force shorter bursts with frequent halts. They advised planks cut to 1-meter lengths be carried on Pioneer handcarts to bridge soft spots for the crawler's nose. The advice sat next to a stark number. Expected field reliability 1 in 2 runs when the wire crossed sharp rubble. A myth took shape that the machine could chase tanks in open fields. Evidence in the test sheet contradicted this. The acceptance course had no moving targets and no rifle fire. Annotations on the sheet in a cramped hand stated that wire survivability under fire was unknown and that crews should practice hugging walls and ditch lines. A unit after action page from a later date would confirm it. Every success came from planned routes, not from free hunting. Case 1 set the tone in Italy. On the 24th of January, 1944, 14th Army Pioneers pushed a crawler along a drainage cut into the foot of a culvert near the Mussolini Canal at a bend south of Padiglione. The operator lay behind a berm while his assistant kept the wire off rusted fence stubs with a hooked stick. The nose slid under the slab and the charge, near 90 kilograms, fired. An American engineer platoon's AAR logged the effect as a lifted slab and a road sag of about 1 meter across. The witness object was the AAR page itself, with a hand sketch of the culvert and a note that the breach delayed a half-track recovery by 1 hour. Analysis after that run turned to timing and reach. From first motion to detonation, the team needed under 10 minutes to cover roughly 150 meters. Wire remained intact, visible in photographs as a dark line across pale soil. Aerial reconnaissance photographs flown 2 days later showed a rectangular crater tucked under the inner face, a signature that the blast rose through the slab rather than broke the front. The culvert's failure forced a reroute of 1 supply platoon along a more exposed lateral, recorded on a 5th Army traffic table. Case 2 tested the promise in hedgerow country. On the 8th of June, 1944, a pioneer detachment under 7th Army rolled a petrol variant into a sunken lane west of Tilly-sur-Seulles. Rain from the previous night left the lane slick. The team laid 2 planks to guide the nose under a farm wall that shielded a British carrier of 50 Division. The charge detonated at the inner footing and opened a gap roughly 2 meters wide. The witness object was a British aerial photo frame from the 10th of June that showed a fresh hole in a wall line and a faint dark streak of wire in the lane. Numbers from the lane matter. Effective wire length used was near 400 meters, leaving a safety buffer on the drum. The run speed hovered at a slow walking pace. The operator paused 3 times to steer around root balls, logged in the detachment's training notebook. A maintenance card recorded track pin replacement the next day due to gritty mud abrasion. British unit pages later noted that small arms fire aimed at the visible wire could not reach it before detonation, because the team had laid the last 20 meters under a plank. Case 3 fed doctrine at a larger scale. On the 14th of August, 1944, as German forces fell back toward the Orne crossings east of Caen, a Corps engineer company received orders to use paired crawlers against a roadblock that British Guards Armored Division had thrown across a farm lane near Troarn. The first machine ran the ditch and died when the wire snagged a barbed hook set low on a fence post. The second followed the same path, but with the wire shifted to the lane's center on a bed of sandbags. The charge broke the roadblock's inner buttress and created a narrow exit for a light truck column. The witness object was a core order overlay with pencil lines marking the paired routes and a note on sandbag placement. The brigade pivot grew from that drawing. Within a week, a training note circulated inside the Corps that advised twin runs as standard when the first wire might snag, and it recommended sandbags laid every 5 meters under the wire in debris-filled lanes. A range table addendum set a preferred detonation height for inner walls at 0 standoff under the footing. A decoded signal summary in late August recorded British units reporting wire sightings and ordering riflemen to focus on fence lines and ditch edges, a direct response to the paired run technique. Training continued under pressure. A logistics vignette from a pioneer park near Bayeux on the 20th of June detailed the shortage of intact reels and the solution of splicing 2 damaged lengths with soldered joints wrapped in rubber tape. Crews practiced continuity checks before each run, using a lamp on the controller face. If the lamp flickered when the reel turned, they switched to a fresh drum. A maintenance clerk tallied reels with more than 5 uses and pulled them from service to avoid mid-run breaks. Weather forced changes. Summer dust in Normandy infiltrated control boxes and caused intermittent steering losses. Rain turned verges to soup and increased draw on electric models, cutting endurance by a third. Crews adopted a simple rule at the end of June: avoid long grass that hides scrap and lay plank bridges where ditch walls have undercut shelves. Aerial photos of the Caen Plain in July show straight plank lines in several lanes, a visual mark of the new habit. The myths faded as the objects accumulated. Unit AAR pages, air photo frames, rail and road manifests, and maintenance cards told the same story. When the wire stayed whole and the route was scouted, the crawler put a heavy charge exactly where it mattered. When fire or snags cut the line, the machine stopped and became scrap. By late summer, both sides treated hedgerow walls and culverts as temporary, not permanent, and that alone shifted the feel of cover. Opponents adapted first with sight and then with steel. In Italy, after the 24th of January 1944, American engineers along the Mussolini Canal ordered riflemen to sweep ditch edges with fire whenever a suspicious dark line crossed light soil. A Fifth Army circular, dated the 27th of January, advised the use of tangles of scrap wire strewn 5 meters in front of key culverts to snag any incoming control cable. A British field note from early June in Normandy added a low trick: set small hooks on fence posts at ankle height to catch a wire dragged along a lane. The first countermove underperformed for a simple reason: the wire lay low and hugged cover. Fire often passed above it, and the machine continued. Aerial reconnaissance frames taken west of Bayeux on the 10th of June, 1944, show intact dark threads under the shadows of hedges even after small firefights. When infantry spotted the control team and fired on the operator instead, detonation sometimes came early, and the charge exploded short, which still broke faces and shook walls. Allied sappers added a new layer. Sandbag skirts around culvert lips hung down to the waterline to absorb blast and catch falling fragments. A Corps of Engineers memo from the 15th of February, 1944, described a skirt of 3 sandbags thickness as enough to block fragments and reduce underslab lift. The method helped only if the charge sat at the front. A belly placement still pried up the slab from under, as shown by the culvert sketch in the American AAR at Anzio. Another adaptation focused on wires as wires. British and American patrols laid tangle-foot rows of thin wire across likely approach ditches at 20-centimeter height. The aim was to snag the cable rather than the machine. A decoded signal summary from 7th Army in mid-June reported several runs halted with the crawler nosed into a wire mesh like a trapped animal. Yet even here, a second run with a shifted wire path sometimes succeeded, as in the Trorn case. A hard limit was baked into the machine. Ground clearance stayed low, and the narrow tracks struggled in churned mud. A maintenance card from a pioneer company near Caen on the 21st of June recorded 3 drive sprockets chipped by hidden rocks in one afternoon. Electric models lost endurance in cold rain and on long climbs. Petrol variants left a faint signature of noise and fumes that warned alert sentries at night. Reliability and field use hovered near 1 in 2 successful runs, as unit pages kept repeating through July. Refinements tried to close the gap. On the 18th of June, 1944, 7th Army circulated a training note urging teams to lay protective underlay paths, a sandbag every 3 to 5 meters under the wire across debris zones, and short plank braces at ditch corners where roots tended to catch. On the 29th of June, a fuse change directive set a shorter electric lead to avoid snag loops around the nose. Early July saw a route change habit. Run along the inner hedge line rather than the lane center to keep the wire under foliage where bullets found it harder to cut. Another refinement shifted weight and profile. Late petrol models arrived with a slightly larger tray and better nose guard against roots. A production tally sheet from Bremen, dated the 5th of July 1944, listed the change as a nose shoe and logged a marginal increase in unit cost. Crews reported fewer nosedives into soft verges when the shoe hit the edge first. A maintenance note 2 weeks later warned that the shoe bolts loosened after 5 runs and required retightening or safety wire. Signal security stayed a quiet asset. Wire guidance meant no radio emission to jam or deceive, so Allied attempts to interfere electronically gained nothing. The device's weakness remained physical, not spectral. Still, British units experimented with smoke to blind controllers. A company log from 50 Division on the 22nd of June noted that white phosphorus grenades thrown along a lane cut off the operator's periscope view and led to 1 premature blast short of the wall. Training absorbed every failure. In one logistics vignette from late June near St. Lo, a pioneer section cut a dummy wire into equal lengths and forced crews to practice continuity checks after each kink and splice. They recorded how often the lamp flickered on the controller and how many turns remained on the reel when faults appeared. The tally led to a rule: retire any reel after 5 complete runs or earlier if insulation showed scuffs at fixed intervals. The quiet beat was cost. Each machine consumed rare parts and time. Production strain in Bremen rose as railway lines took bomb damage in July, delaying shipments to the west. A ferry manifest on the Orne River lists a barge that diverted twice in mid-July to avoid air raids, adding an hour to each leg and forcing crews to wait for spares. Field units stripped damaged machines for wire and pins, leaving skeletal hulls in hedgerow ditches. Limits also came from doctrine above the sapper's level. Corps commands rationed charges by block count rather than by chassis to prevent waste on targets that infantry could clear with picks and smaller satchels. Orders from 14th Army in late January and from 7th Army in late June both demanded that crawlers be used only where their underface placement offered a decisive saving in time or risk. The discipline kept the machines from being thrown at every wall and conserved them for culverts, roadblocks, and parked hulls that mattered. The opponent's countermoves never fully erased the device. They did make it slower and more deliberate. Wire drags, sandbag skirts, and tanglefoot strips forced new route sketches, longer preparation, and paired runs. The refinements, nose shoes, underlays, fuse changes, and lane choices pulled success back toward even. By late July, both sides had settled into a new normal where cover held only if the wire could be cut or the route broken. Immediate outcomes showed on traffic tables and bridge lists. At Anzio, after the 24th of January 1944, culvert breaches forced Allied engineers to reroute supply in several sectors for hours at a time. A 5th Army movement sheet from the 26th of January recorded detours that added 10 to 20 minutes per convoy along the Mussolini Canal laterals. In Normandy, after the 8th of June, hedgerow gaps opened from the inner face allowed German light traffic to slip through lanes threatened by British patrols, logged in 7th Army road usage notes for mid-June. Some blows landed on armor. A British unit page from 50 Division, dated the 10th of June, notes one carrier disabled when a wall behind it lifted and dropped shards into the engine bay after a crawl-under blast. An American maintenance log near Isigny on the 13th of June lists a half-track with sheared track pins after blast under the front run. The numbers were small, but the psychological shift was clear in the notes. Crews began to park further from walls and culverts and to post riflemen to watch ditch lines for wires. Operational effects remained bounded. The machines saved pioneers time on select tasks. At Trorn on the 14th of August, the paired run drill cut a roadblock clearance from an hour with picks and smaller satchels to under 15 minutes, according to a core overlay with penciled estimates. Along the calm plain in July, underface blasts opened narrow breaches that allowed staff cars and small trucks to move where hedgerow banks had been thought solid. Yet the devices did not change the larger tempo of battle. Artillery, armor, and air kept the pace. Still, a rule had shifted. Cover no longer promised immunity simply because the face looked thick. The new rule said any cover with a reachable underface was temporary. Aerial photo frames from June and July in Normandy show multiple small inner wall breaches with rubble spilled outward, a pattern different from shell hits that scar front faces. Unit AAR pages from both sides learned to describe walls by their footing and culverts by their slabs, not just by thickness. Costs accumulated as well. Production tallies from the Bremen works in July show fewer shipments west as rail damage mounted. Ferry manifests on the Orne, log delays and detours. Maintenance cards piled up with notes on worn reels, cracked insulation, and chipped sprockets. Field units cannibalized damaged machines, leaving hulls as donors for pins and wire. The tally of useful runs stayed close to 1 and 2, a ratio that never rose far. Aftermath in doctrine took a quieter path. German pioneer manuals in late summer updated drills to assume paired runs and to emphasize protective underlays for wires. Allied engineer notes shifted to counterwire habits, hooks on posts, tangle strips across lanes, and sandbag skirts on culverts. By August, both sides wrote orders that named the machine, the wire, and the underface instead of treating cover as a generic mass. The long tail ran past the war. The method, send an unmanned carrier to deliver an explosive into a place hostile to a human body, did not die with the last crate. Post-war engineer schools kept the idea alive in training notes about remote breaching and robotic carriers. Wire guidance gave way to radio and then to encrypted control. But the old logic stayed. Low, slow, and precise beats bold when the gap is narrow and the risk is high. Maintenance cards from later decades read like the old ones: track wear, controller faults, and the need for patient lanes. Legacy also shows in how units think about cover. Modern manuals teach that cover must be judged from all faces, including the belly and the back. The habit comes from many sources, but the small tracked box with a heavy nose helped write it. Aerial photos in later conflicts show inner face breaches as a common signature at culverts and gatehouses, a distant echo of hedgerow gaps west of Bayeux. On the human side, the crews learned a certain stillness. Controllers lay behind berms with a periscope and watched a low shape inch toward a target. Assistants kept a wire clear with a stick and counted sandbags under their breath. The act took time, and the clock inside a battle rarely gives time freely. That the device worked at all in the noise of Italy and France says much about the small decisions written into training notebooks and maintenance cards. Outcomes by date chart the arc. January in Italy saw the first breaches under slabs. June in Normandy put interface wall gaps on aerial frames and taught both sides to look for wires. August near the Orne wrapped the doctrine into paired runs and sandbag underlays. By September, crates were fewer, reels were worn, and the retreat east consumed the remaining machines as bridges fell and roads clogged. The old map pin remains. The bend on the Mussolini Canal south of Padiglione sits quiet now. Reed beds still shift in wind along the banks where an operator once hid with a wooden controller. The slab that lifted and sagged in winter mud has long been replaced, but the rule it broke never fully mended. Cover holds if the belly cannot be reached. If a low track can find the underface, the promise is thin. The legacy sits in archives as well as in doctrine. Unit AAR pages, production tallies, ferry and rail manifests, aerial photo frames, and maintenance cards mark a brief span when a small machine carried a heavy charge into forbidden spaces. Simple numbers ride those pages. 500 meters of wire, 90 kilograms of explosive, 1 and 2 runs reaching the point. They show limits and outcomes at once. They also show a line from a gravel lot at Kummersdorf to a hedgerow lane west of Bayeux and back to the quiet bend on a canal in winter light.